information such as universal set, union of a set, intersection of a set, and complement of a set are very, very important. Let's take a look at them one after the other. The universal set. Universal set is usually represented by this symbol. This is a symbol of universal set. Now, universal set means all elements that any other subset have is in it. It can even have some element that none of them even have at all. What I mean by this, let's assume I represent universal set by this set of elements of this nature. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For your understanding, I'm going to make use of these figures. Now, this is a representative of a universal set. Now, any other element that are going to be in that set will be a subset to the universal set. Now, if inside the universal set we have set A, which is 1, 2, 3. We have B, which is 3, 9, 10. And we have C, which is 4, 5, 6. Now, all these elements, all these sets that we have here, A, B, and C, you can see that all their elements are found in the universal set. And there are some other elements that are in the universal set that they do not have at all. If you place them inside a Venn diagram drawing, you will discover that there will be some element that will be shading away. When we get there, we'll still talk about what is meant by, when we get to what is meant by complement, you will know the value of what I'm talking about now. Let's move on to what is meant by union of a set. Union of a set is represented by this symbol. Something like U, but not U. That is what is called union of a set. Now, union of a set means that this will encompass or is going to take into making use of all the elements of the two sets being in consideration. Now, it can be two sets. It can even be more than two sets. We can have something like A union B union C. For instance, if we have here now, if we are asked to find the value of A union B, it means that we should mention all those values that are in set A and in set B together. But take note of one thing. If two values, if a particular value, for instance now, if you are talking about A union B, you can see that we have 3 here, we have 3 here. Only one of them is going to be made use of. You must not repeat it more than one time. For instance, we have A union B will be equal to, what do you have here in A? 1, 2, there's 3 here, 3. What do you have again? 9, and we have 10. This is element of A union B. And if you look at this set that we have here now, if I ask you what is the number of this set that we have here, you'll be able to agree with me that the number of this set is 1, 2, 3, 4, 5. So, number of set n is equal to 5. Where the number of subset, which is equal to 2 raised power n, will be equal to 2 raised power 5, which is equal to 32. When you say 2 raised power 5, you get the value to be equal to 32. I've been able to deduce what is meant by union of a set here. Then I try to also bring in what we have done earlier into what we are doing right now. that is the number of this set, then the number of this subset of A union B that we have here. Now, we have been able to talk about the universal set. We've talked about the union of a set. Let's now talk about the intersection of a set. The intersection of a set is represented by this symbol. It looks like N as well. This is the symbol that we use in representing what is meant by intersection of a set. Now, what is meant by intersection of a set? Intersection of a set is what is common to both sets or to the set that you are being considered. Because why I do not restrict myself to making use of both is that you can be given more than two sets and you are asked to find their intersection. You only look for what? The values that are common to all of them. Only that value will be taken out as the intersection of such a set. Now, let's look at what is meant by intersection of the set A from this example given to us. A intersection B will now be equal to, what is value of A intersection B now? You can now look at it, which value is common in between them. That we can find in A, as well we can as well find in B. So if I want to look at it very well, there is 1 here, no 1 here, so it is not an intersection element. There's 2 here, there's no 2 here, 2 does not intersect the element as well. There's 3 here, there's 3 here. Oh, I'm going to write 3 down first. So, what other value is here and here? No other value. So in that regard now, I can now say that A intersection B is equal to 3. You can be asked to find A intersection B, number of A intersection B. What is the number of A intersection B? As we have done here, just one element. 1. Okay. N is equal to 1. Number of subset. Number of subset of A intersection B will be equal to 2 raised power of N, which is equal to 2 raised power of 1, which is equal to 2. So we have been able to know what is meant by A intersectional and that of the union, and what is also meant by universal set. You'll be wondering that we have not even mentioned what is in this set of set C here. Don't bother yourself yet. We have not even touched what is in this universal set. I'm going to touch them right away now. But before I go into touching them, let me talk about what is meant by complement of a set. Complement of a set is usually represented by either you put this symbol as a kind of power on a particular set given to you, or you put this symbol there. For instance, if I'm talking about complement of set A now, of A that we have here, I will write it as this: A or A. This is what is meant by complement of set A. What is meaning of a complement? A complement are those elements that are in the universal set but are not in the set in question. For instance now, if I want to mention what is the complement of set A, I will take a look at it and I will say that A, what is the value of A? 1, 2, 3. So A complement now will be equal to, what are those elements that are A but are not in this set A? So we can now set those elements are 4, 5, 6, 7, 8, 9, and 10. These are the complement of this set A that we have here. Now, for also have the value of A union B, union C. I want to make use of something here now. You can see that I'm making use of the 3 of them together right now. A union B union C, that is all the elements that we have there. Take note, if an element is mentioned more than one in the 2 of them, you only take one of them. Now, what are those elements? Those are 1, 2, 3, We have 4 there. Yeah, there's 4 here. 4. We have 5, 6. They have no 7. We have no 8. Then we have 9. Then we have 10. Now, these are the elements 1, 2, 3, 4, 5, 6, 7, 8 is not here. 9 and 10 is there. For instance, now I can be given, or a question can be thrown to you that you find the value of A union B union C complement. This will be equal to those values that are in universal set but are not in this set that we have here. What are those values? Just 7 and 8. They are the ones that are not here. That is 7, 7, 8. That is a complement of a set. That is what we mean by complement of a set. If I even ask you to find the C complement, find C complement will be equal to, C complement will be equal to, what are those values that are inside it? 4, 5, 6. The C complement will now be 1, 2, 3, 7, 8, 9, 7, 8, 9, 10. So also, on your own, quickly do what is meant by A complement, B complement. The types of set. Now, I want to start with what is meant by empty set. Empty set is given this symbol. Nothing will be written inside it. That is what is called an empty set. That is the symbol. For instance, you can just be given x is equal to this. What this means is that x is an empty set. Now, when x is an empty set, it means that there's nothing that can be of that nature. For instance, you are given a set that the set is a child born without a head. Can that be possible? So that is there's nobody that is on this planet Earth that do not have a head. So that is an empty set. That is very, very sure is an empty set. So something that is not possible, that is cannot be in existence, is going to be an empty set. Other set types I'm going to talk about is the one we call the finite set. Finite set, as the name implies, means something that is limited. It has an end. For instance, if there are a lot of finite set that we have, number of cars we have in a particular place, it can be counted. Number of a cube in the sugar pack, number of fowls in a pen, number of animals we have on the field, number of students in the classroom. Those numbers can be counted. They are going to be called what is known as a finite set. It is called a finite set. The set that has a limited number that can be counted. Even if we have 10 million of it, it can still be counted. Number of human beings that we have in the world is also a finite set, because according to the record we have right now, we have the population around over 7 billion human beings that we have on the planet Earth. Even the animal on the field, since we can have a method of counting them, they can be categorized under a finite set. Now, another type of set we have is called the infinite set. As the name implies, infinite set, that is, the element of that set cannot be counted. The element of such a set cannot be counted. For instance, if I am given to count as the element of a set is the number of ears on my head, oh, that is going to be a little bit difficult. That is not going to be counted at all. Or you have the positive integers. Positive integers too are uncountable too as well. We have uncountable. You know, when we are doing the counting, you will get to a value that you will say it is uncountable. Uncountable figures. So those are our positive integers as well. Or you are asked to count the number of sand grains that you just pick up from the soil. You will find it very difficult. You find it, it's not going to even be, you cannot even count it. So we call it infinite set. What is now another type of set is called disjoint set. That's what I want to say earlier. What is now mean by disjoint set? Disjoint set. You can see, as the name implies, disjoint. That is, they do not have anything that link them together. They are separated. These are the type of sets that do not have anything in common with one another. Disjoint set can be given between two sets. If you can have, for instance, I have A equal to set X, sorry, let me make use of set X equal to A, B, C, D. Those are the elements we have in this set X, and set Y equal to F, G, H, W. You can see that there is nothing in common between these two sets. So, or we just say Y. Let me give an example now. Let me have it. Y, 1, 2, 3, 4. Now, you can see that there's nothing common or intersect that can intersect with one another between these two sets. So we can say that X and Y are disjoint set. X and Y are disjoint set. So there's nothing that is common between them. Now, another example of a set is what we call the equal set. Equal set, as the name implies. Equal means the same value. So what is meant by this set is that the value that in this particular set is also going to be the same value in the other set, neglecting their method of arrangement. For instance, for equal set now, I can have X is equal to A, B, C, D. And I have set Y to be equal to B, A, D, C. Now, I can now say that X is equal to Y. That is, X set, the number of elements or the element you have in set X is the same element you have in set Y. They must not be higher than one another for them to be equal to each other. They must have the same number of elements with one another, and as well, all the elements there must be the same value, neglecting their position on where they are inside a given set. Now, another example of types of set we have is called the equivalent set. Equivalent set. Now, equivalent set is said to be the set that have the same number. That is, set of the same number. For instance, now I can say that set X here is equivalent to set Y, because the number of set here is 1, 2, 3, 4, and the number of elements in set Y as well is 1, 2, 3, 4. You can see the number of elements we have here is equal to the number of elements we have here. So in that set, I can say that n number of X is equal to number of Y, then X is equivalent to Y. That is, set X is equivalent to set Y. I hope that is very, very clear to us. Now, another forms of types of set I'm going to talk about here is called the difference set. Difference set. I'm going to do the analysis here. Difference set. Now, difference of a set. When a set is different to one another, it means that if two sets are given to you, for instance, if we are given set X to be equal to A, B, C, D, E. Take note of what I've written is A, B, C, D, E, and we are given set Y to be equal to B, D, E, F. Now, these two sets that we have here, for them to be different to one another, we can only have what is the difference between A and B, or what is the difference between B and A. And you can have it in this form and say that find X minus Y. When you are given this kind of a question here, for any set given to you, find X minus Y, it means find the difference between X and Y. Now, X minus Y will be those elements that you have inside X set that are not in Y. So X minus Y now will be equal to, what is the element you have there? You have A here, you do not have A here. A, X minus Y, A, you have A in X, we do not have it here. B is here, B is here, D is here, D is here, C is here, C is not here, C again, E is here, E is here. So X minus Y, or the difference between X to Y, is AC. Now, Y minus X. Y minus X can also be find out, that is, element that is in Y that is not in X. That is Y minus X. What is that element that is in Y? You can see that B is here, B is here, D is here, D is here, E is here, E is here, F. That's F, F. That is the only element that you have in Y that is not in X. That is what is meant by difference of a set. You have to. The question here now give us the values of a universal set, which says a universal set is a set of number that is less than 50 but greater than 20. So those numbers will start from 21. It is greater than 20, then they cannot go beyond 49. So the last number will be 49. And it also gave us the value of A, B, C. A is a perfect square. So let's write those values out first. Then we'll look at the question that has been given to us here. Now, the universal set, as we have it, according to the information given to us, will be in this order. Universal set will be 21, 22 is a natural number, or 23, 24, that is greater than 20, 25, 26, 27, 28, 29, and so on and so forth to 47, 48, and 49. So it's going to stop at 49. That is the universal set. What this means is that you are going to have set of numbers like 30, 31, 32, 33, 34 as it gets to 47 as well. In order for us to save the space, that is why I pull this dot there. I think you all understand what I'm doing right now. Now, A is a value that is, it says it's a perfect square. Don't forget, I have already mentioned it earlier. When you are given a universal set, all other sets that are given to you will be a subset to the universal. That is, those values or those elements that will be in those sets will be taken from the universal set. They cannot go beyond the universal set. So that is, you cannot have an element of this one to be around 20 or 18. No, they must be within this value of the universal set. Once the universal set has been given to us, so you must work towards it. Now, the value of A here, as we are given, we are asked that they are perfect squares. And you know what is meant by perfect square is when you multiply a particular number with itself. The value we get is called a perfect square. So if you multiply 1 by 1, that is 1. 2 by 2, 2 multiplied by 2, that's 4. So perfect square we'll begin having will be 1, 4, 9, 16, and so on and so on. Now, those ones that are going to be found in between this particular universal set that we have here will be from, I think we're going to have 25. Then, which one do we have again? We are going to have This 25 is 5 times 5. Then let's think about 6 times 6 now. 6 times 6 is 36. And the next one, which is going to be 7 times 7, will be 49. I think that is the last number that we have here. Now, we have been able to bring out the values of A here. Then the value of B, which is said to be the factors of 12. From this value we have here, factors of 12 are those factors that when they divide 12, they are going to give us a whole number. Now, factors of 12 can now be 24. So when you divide 24 by 12, you are going to have 2. You can have what again? You can have 36. When you divide 36 by 12, you are going to have a whole number. Then we can also have what again? What value do we have again there? You can also have 48. Those are factors of 12. Those values, any other values that we have here, when you divide it by 12, you are going to have a remainder. Now, the last value we have here, which is we are at the last set, is said to be the prime numbers. The prime numbers that are found within this universal set. Now, what is a prime number? We have been talking about it in this class over and over again. I'm still going to mention it again. Prime numbers are numbers that can only be divided by 1 and itself. If you use to divide any other number, you are going to have a remainder. For us to have a whole number, you must only divide it by 1 and itself alone. Now, those set of numbers from here could now be, if you look at this 27 now, 21 now, 21 divided by 3, you can have 7. So you cannot use this, you cannot use this. 23 is one of the prime number there. 23, 24 no, 25 no, 26 no, 27 no, 28 no, 29. What about 29? Oh, 29. 29 is another prime number there. We have 31 again. 31. After 31, we have 30. We're going to have 37. 37. After 37, we're going to have what we call 43. After 43, what do we have? We can also have 47. 47. There's no number you can use to divide any of these values here except 1 and itself without having a remainder. Now, we've been able to bring out those values now. So let's now go into the answering of the question proper. The first question says we should find the value of A union B. A union B. A union B, as we have it here, you know, A union B will be all the values that we have in the two sets. They will be brought together. Remember that when a particular value occurs 2 times, you just mention it once in the answer you are going to provide here. So A union B will be, we have 24 here, so let's write it alphabetically. So we're going to have 24, 25 here. After 25, we have 36, we have 48, and we have 49. That is the value of our A union B. That is a value that is going to give to us. So the next question that we have here says that we should find the value of A intersection B. A intersection B, put it in bracket, then union C complement. Union C complement. Now, as we have been doing in our earlier class or earlier questions that we have solved, let's try to first of all find the value of A intersection B. A intersection B will be equal to, now what is the value that are common to these two sets here? We have only 36, that is 36. Now, C complement. C complement, as we know, C complement are the values that are inside the universal set, but not in C set of C itself. So C complement will be That will be 21, 22, 21, 22. What else? We have 23 here? No. 24, 25, 26, 27, 28. 24 to 28. What do you have again? We have 31 now. After 28, we have 29 here. That's 30. 31 is here now. No. 30. 30. What else after 31? That was the 32, 33, 32, 33, 34, 35, 36. So we have 37 here. So after 37, we have 38, 39, 40, 41, 42. Oh, what do you have again? We have 43 here. So we're going to have 44, 45, 44, 45, 46. We have 47 here. So the next one will be 48, 49. That is the value of C complement. Here, what I have here is 24 to 28. I mean 21, 22, 23, 24, 25, 26 to 28. That is what the meaning of what I have here. So now we go ahead in solving the question paper. We are now find the value of A intersection B union C complement, which is going to be just the addition of 36 to what we have here. And you can see that we have already a 36 is also part of what we have as C complement, so it can as well be equal to C complement. It is the same thing as a C complement, because all the value we have here, we just need to put this one and add it to it. That is the value we're going to get for this expression that we are asked to find it. Now, the next question says we should find the value of A complement intersection B complement union C. A complement intersection B complement union C. That's question 3. Now, we need to write out the value of A complement first. A complement will be equal to, so let's write that one out, except 25, 20, 36, and 49. That will be 21 to 24. That's first one. Then 26 to 35. That's next. Then 37 to 48. All those values falls within this range will be written down as value for A complement. That is those values that are found in the universal set but not in set A. Now B complement as well. B complement will be equal to, that will be 21 to 23. We have 24 here. You are not going to include it again. Then after that we have 25 to 35. So after that we have 30 from 36. Now that we have 36 here, then with 37 to 47. After the 7 to 47, we still have a number here. After 48, which is 49, then comma 49. So those are the values we are going to, because of the limited space we have here. That's why I'm just shortening it, and because of our time as well. So we are going to have a union of it with the C values here. Now, according to what we have here, in the C we have 23, 29, 31, 37, 43, and 47. So we can now say that A complement intersection. Now let's find the value of intersection B complement now. A complement intersection B complement. Let's find that one out first. So that will be equal to, what is the common value there? 21. That will be 21, 22, 23. There's no 24 here. So in B, there's no B complement, there's no 24 there. So you can also bring out those one out, 21, 22, 23. Those one are there. After that, we have intersection is what we are doing. Remember, we have 25, 26 to 35. This one is 20. This one is having 25. So there's no 25 here. So 26 again, 26, 27, 28, 29, 30, 31, 32, 33, 34, and 35. 35. So that's, then we are having the value from 37 here, which is also 37 here as well. Some values have been left out. 36 has been taken out. So 37 to 47 here. So this one as well be 37, 38, 39, 40, 41, 42, 43, 47, don't forget, 44, 45, 46, 47. Then this one is having 48, this one doesn't have 48, this one has 49, this one doesn't have 49. So that is, those are the values that we have there. Now, we now say, we are going to now look for the A complement intersection B complement, which we have here already. This is their intersection values. Then union C. What are the values we have in union C? 23 is here, 23 is here. 29 is here, 29 is here. 31 is here, 31 is here. 37 is in C. 37 is in A complement intersection B complement. 43 is here. 43 is also here. 47 is here and 47 is here. So I can now conclude that A complement intersection B complement union C is equal to A complement intersection B complement. A complement intersection B complement, because all the values that are in this C are as well here. So there is no need for us to give ourselves so much stress any longer. Now, the question, the fourth question there, it says that we should find the number of A. Number of A. Number of A. Now let's look at the number of A that we have here. The number of A, we have how many elements there? 1, 2, 3. So number of A is equal to 3. Number of A is equal to 3. In case this is not part of the question anyway, but I am now bringing it inside that we are asked to find the number of subset of A. Number, let me take that one as number 5 now. Number of subset of set A. So that will be equal to 2 raised power of n, which is equal to what? 2 raised power of 3, which is going to be equal to 8. So whichever way the question is given to you, that is how you should be able to have a little idea on each of the question and how to solve them appropriately. Stay tuned for the next question. Now we want to look at what is meant by Venn diagram, and we are also going to show you how the relationship between different sets can be shown with a Venn diagram. Venn diagram is a form of diagram that is designed to show relationship between sets. When you have a particular set and a particular set, I've been mentioning so far universal set, set A, set B, set C, or you can be given any forms of name for a particular set. This Venn diagram will show it in form of a diagram, and you can as well deduce a particular value or whatever question that is given to you as far as a set is concerned. You can use a Venn diagram to also resolve such a question. So let's now look at different forms of diagram that can cause up in Venn diagram and the meaning of those diagram. Now, I'm going to start with this diagram we have here. I have this. If I have a diagram of this nature and I have this within, this is a set on its own. Now, if all this place is shaded, the shaded portion here, if this is set X, the shaded portion here is called X. This is the what? The shaded portion is refers to as X. That is, the set is the one that is being shown to us. Whatever element that are inside here are the one that we are asking of the question of it. Now, I have this again. In this Venn diagram, you are going to have a universal set here. All the Venn diagram will always have a universal set outside, which is going to give us a particular value. Don't forget that every other set are subset to universal set, as each set are also subset to itself. So take note of that. Now, if you have this, this is set A, this is set B, and this is the portion that is shaded. This portion here is shaded like this. The shaded portion here is referred to as A union B. Is referred to as A union B because it is talking about all the elements that you can find in A and that of B. That is what this set is telling us. Now, if you look at this set here, I'm going to have a set of two sets as well of A and B. I call this A, I call this one B. You can see we have two circles there. Each of the circle is representing a set. You can see a circle here represented a set, a circle here is representing a set, and a circle here represented. And you now have this portion here shaded. The portion shaded here is referred to as A intersection B. A intersection B. What is the meaning of A intersection B? We have already talked about it. A intersection B is the common element to the two sets in question. The element that are common to them is the value that are found in this region. Now, we move on to another forms of diagram. If I have this diagram of this nature, I have it this way. We have this is A, set A, this is set B as well, and I have this outside part here. Don't forget we have the universal set outside here. This outside part here are shaded. The shaded portion here is referred to as A union B, put it in bracket, complement, or A complement intersection B complement. Look at it. The shaded portion are not for any of these set of A or this B here. But the shaded portion are outside there. Those are the values that are found in the universal set that are not in this A and B. So those values will be A union B, put it in bracket, complement, or A complement intersection B. If you try to work it out, you see that you're going to get the same value for it. Take note very well. This is very, very important. Take note of each of these diagrams. They are very important to consider when you are trying to deal with set theory. Now, I'm going to have another one here. I have another one here. I call this is the only set here. This is X. This X. And I have this portion here shaded. The portion that are outside that set circle. You know, this is a set itself. This is a universal set. This set here, somebody should give me the answer to this. This is going to be what? X complement. X complement. That is, the values that you are considering here for this shaded portion are those values that are in the universal set but are not at all in set X here. Take note of that. So, also, if you have a kind of diagram that is of this nature, like you have these like this universal set. What is the meaning of this? This means that X and this is X, this is Y. X and Y are disjoint. X and Y are disjoint set. There's nothing in common between the two of them. You can only find the union of the two of them, but you cannot find the intersection of any of the two of them. That is the meaning of such arrangement. Now, if you have this, You have this set like this. This is set, let's call this one X. And we have another set within. Sorry, this is going to be, it must be within, very well. You have another set within, which is Y. This is Y is a subset of X. This is X, don't forget. It means that Y is a subset of X. Y is a subset of X. That is the meaning of this particular diagram or Venn diagram that we have here. You can see Y, it means that all elements in Y can be found in X. In other words, there are some elements that will still be in X that Y will not have. So X is a subset to Y. Y will be a superset to X. That is, Y is a subset to X. Yx is going to be what? A superset to X. You can see if you look at the diagram from this X here, if you look at it, this is a superset. That is, X is a superset of Y. Now, I move on to another diagram. This set of diagram I've drawn here so far are relating the diagram, Venn diagram for 1 and 2 set ideology. Then I'm going to talk about 3 sets now. Now, if I have this set arrangement, I have it in the Venn diagram like this. Don't let it touch it. It must not touch any part. This is X, this is Y, and this is Z. If only this portion is shaded here. Somebody, I think you have all known the meaning of this right now. This one's X intersection Y intersection Z. X intersection Y intersection Z is this shaded portion here. X intersection Y intersection Z. That is the shaded portion there. Now, if you have this kind of arrangement like this, you have this. This is X, Y, and this is Z, and you have all these regions shaded. This one is X union Y union Z. X union Y union Z. That is the meaning of this particular diagram, Venn diagram drawing. Now, more diagram I'm still going to show for you now. Take a look at this very well. And still on the Venn diagram, I have this again. If we have this kind of a drawing, we have this with 3 sets within. We call this A, B, and C. You have only this place shaded. This one is only talking about B and C. B and C are the region that this shaded portion is concerned about. You can see that this A does not have any of this region shaded. So A has been ostracized out. A does not have anything to do with this shaded portion at all. But C is the intersection between C and B that is shaded. So this will be A complement intersection B intersection C. You can see A complement means that those values that are inside the remaining part that do not have anything to do with A itself. None of the value of A, none of the element of A will be inside this shaded portion given to us. But it is going to be the intersection values that you are going to bring out here. Now, I have another one. This is the universal set. I have another drawing here like this, which is going to be for the 3 set as well. I have set, let me give it set X, Y, and Z. I have this portion alone shaded. This portion alone is shaded. You can see that when I shade only this portion, when this portion alone is shaded, there's nothing from this Z that is shaded at all. Even its intersection is not concerned. Likewise, Y. none of their portion is related to that shaded portion. So this one will be x intersection y complement intersection z complement, because none of their region has effect with this shaded portion. So that is the meaning of this particular Venn diagram. I have another Venn diagram I want to quickly show for between two sets. Now if I have a kind of arrangement of Venn diagram of this nature, which is giving me x and y, I have this, and this portion alone is shaded. This is x, this is y. This means x minus y. X minus y, that is, the values that are found in x excluding anything in y. This is the difference of a set. Difference of a set, which is can as well be of the value of x intersection y complement. X intersection y complement. So if you have it in this way as well, you have it x, this is y, this is x. You have only this y region here. This is going to be y minus x, which is also equal to or x complement intersection on y. X complement intersection y. So take note of it as well. Now we move on. When you have a kind of drawing of this nature, this is x, y, and this is z. What is the meaning of this? It means that x and x, y, or z are disjoint set. Disjoint set. That is, there is no common element that any of them have. No common element is found between any one of them at all. That is the meaning of such an expression. So it's also, if you have this, I think we have been able to show this in there. You have this is A, and this is having an inside here. This is B. This is A is a subset of B, or this is B intersection A. It will be equal to A. You understand what this one mean? It means that B intersection A will be equal to what? A itself. Anything that is common to them is also the value inside the A. It's going to be the value of A. So when you bring it out, anything outside this A do not have anything to do with A. So B intersection A will be equal to A itself. So if you have this as well, you have this kind of diagram. I call this M. I call this, you have this one again in it. And you have this. And we have this again. So this kind of diagram, this one is N and this one is D. We have M, L, N, D. It means that D intersection M is a null set. You can see D intersection M here is going to be a null set. There's nothing that is common to them. That is, B is D and M are disjoint. They do not have anything in common at all. They do not have anything in common at all. And then this expression can now give us that, or this diagram can now tell us that L is a subset to M, where M is a superset to L. You can see M is a subset to L is a subset to M, where M is a superset to L. So that is how those diagrams are arranged. Now we want to consider how we can count an element of a given set of a given set given to us. Now, you're going to look at the way we can be able to cancel properly now. Now, let's assume we are given to set A. A is given to be, the element you have in A are A, B, C, and D. And we are also given another set B, with the following element A, B, C, D, E, F. Now, looking at these two sets now, we have A to be A, B, C, D. We have B to be A, B, C, D, E, F. There are some things in common within their elements that we have here. Now, the first thing I want us to take note of is this. Considering the counting of elements in a set. Number of elements in set A, that is number of A, will be equal to 1, 2, 3, 4. 4. It is clear to all of us. Number of elements in set B is how many? 1, 2, 3, 4, 5, 6 is equal to 6. Now, if I now add it together, if I say number of element A plus number of element B will be equal to 4 plus 6, which is equal to 10. This is not correct to the number of elements. This is not correct to the number of elements. Why? Because there are some elements that are counted twice, more than once. You can see A is counted more than once, B is here, B is here, C is here, C is here, D here, D is here. So this arrangement here cannot be given to find the total number of elements in the both set. But if I want to find the value of number of A union B, I can find the value of number of A union B. I will write those elements here now. The A union B values will be A is here. Don't forget, I have earlier told you that once they are found more than once in any of the two places, you write only one of them down. B, C, D, E, F. That is the number of A union B, which is the correct number of total number of elements in A and B. Now, but when we do the addition here, we get 10, which is not corresponding to this one that we have as number of A union B, which is equal to what? 6. Sorry, this is A union B itself. Number of A union B is equal to 6, which is not corresponding to these. They are different to one another. They are not in an, but this is the correct value. Now, for finding the number of A plus B, we can now say that number of A union B will be equal to number of A plus number of B, number of A plus number of B, minus number of A intersection B. Number of A plus number of B minus number of A intersection B when you are considering only two elements. Now, I think I should be able to find the value of my number of A union B now. Number of A union B, now I cannot get it to be equal to number of A. What's the number of A? 4 plus number of B is what? 6 minus number of A intersection B. What are those numbers of values that are common to one another? I can work it out here. Number of A intersection B from here will be what? Now let me first of all find the value out. Will be, what are those values? That's A, B. Those are the values that are common to the two of them. C and D. You can see that E and F are only found in this set B. It's not available here. So the common element there, A, B, C, D is there. A, B, C, D is also here. Those are the common elements, which is number of A intersection B is equal to what? 1, 2, 3, 4. So this one will now be what? Number of A union B, as I've given the formula out here, is equal to number of A plus number of B minus number of A intersection B, which is equal to what? 4. Which is equal to what? 4 plus 6. 10 minus 4 is equal to 6. Which is equal to the way when we do the value here. You can see it. It's very, very equal to this. So that is how, this is the formula you use for two elements when you want to find the number of A union B, or you want to deduce the value of number of A intersection B, or you want to find any of these elements. If this is given to you, this is given to you, this is given to you, but this one is not given to you, you can easily use this method to find the value of any of them in that order like that. I'm also going to take you to how we can do the formula for number of A union B union C. The formula to get number of A union B union C. So let's look at that now. We've been able to find the value for number of A union B. Number of A union B. So that is when we are considering two sets in question. So which is equal to number of A plus number of B minus number of A intersection B. That is how you find such answer to that question. This is for two sets. When you are talking about two sets now, when we are not talking about three sets, I'm not making use of A, B, and C now. Thinking of three sets, THR. Three sets now. I'm talking about sets A, B, and C. Now, for us to find the number of A union B union C, number of A union B union C will now be equal to number of A plus number of B plus number of C. You can see you have to take each of them one after the other, write their number and add it together, minus, then you are now going to look at intersection of how they can relate with each other. You know that A can intersect with B, A can intersect with C, and B can intersect with C. That has completed. Minus each of those intersection values, minus number of A intersection B, minus number of A intersection C, minus number of B now intersection C. You can see there is none that has been left out, plus number of A intersection B intersection C. That is how you get the value for this kind of when you are finding the number of A union B union C, or when you are trying to work a question that has to do with the numbers in set theory. Now we are going to look at a question right away. Now I have the question that's going to be coming up now. The question says that in an examination malpractice committee, the examination malpractice committee in its last meeting found out that 36 students cheated in the NTS 119, 22 in NTS 114, 22 in NTS 114, NTS 114, 22 cheated. Here, how many cheated in 119? 36. Then 15 in both. Find the number of students that cheated. 15 students cheated in both. NTS in both. So I call this A, I call this B now. In both A intersection B now. That is both. That is where that is what is common to the two of them. The cheated process occur between of them. How many of them cheated? That is 15. Now, if I call this A, number of A as we have it here is equal to 36. Number of B is equal to 22. where the number of A intersection B is equal to 15. Now, having got all this now, find the number of students that cheated. We have not known the total number of students that cheated. So, but the examination malpractice committee only bring out these particular figures for us. For us to learn the number of students that cheated now, number of students that cheated will be equal to number of A union B, because these are the cheated set of people. They cheated in this, they cheated in this, but some of them, 15 people, 15 students among them cheated in the two of them. So we can now say that number of A union B will be equal to number of A plus number of B minus number of A intersection B. So which, for us to find the value of those students that cheated totally now, will now be equal to number of A union B will be equal to number of A is what? 36 plus 22 minus 15, which will give us 36 plus 22. That will be equal to 58. 58 minus 15 will give me 43. So the number of students that cheated are equal to 43. Number of students that cheated in that examination is equal to 43. So you can see the way we have been able to bring out this information out with ease.